Okay, so these notes are over the properties of logarithms. So we have 3 different properties we're going to be focusing on today. The first one is the product property. And the product property states that if you add together 2 logarithms that have the same base, whatever you're taking the log of, you can multiply together. So here, log base b of ilm plus log base b of n equals log base b of ilm times n. So using real numbers here, I've got log base 4 of 2 plus log base 4 of 32 equals x. So I can make that one logarithm by saying it's log base 4 of 2 times 32 equals x, which is the log base 4 of 64 equals x. And now I can actually solve this. And to solve this, I'm going to put it in exponential form. So my base is 4 raised to the x power equals 64, which means that x equals 3. Next up, I have log base 6 of 4 plus log base 6 of 54 equals x. Both of my bases are 6, so I can multiply the 4 and the 54 and say that it's log base 6 of 4 times 54 gives me 216, which equals x. And now if I wanted to go through and solve it, I can put it in exponential form. So 6 to the x power equals 216, which means that x equals 3. My next example, I have log base 7 of 2 plus log base 7 of 171.5 equals x. Both of my bases are 7, so I can multiply the 2 and the 171.5 together. So I get log base 7 of 343 equals x. And so if I wanted to solve it, I could say 7 to the x power equals 343. So x equals 3. So when you add 2 logarithms together, you can really multiply. When I'm expanding, so I'm just writing it from the short version to the long version. So it's multiplication. So log base 8 of 7 times 11 can be rewritten as log base 8 of 7 plus log base 8 of 11. The next one, log of 9 times 4. So that's a base of 10. So that's why it's not written. So I can rewrite this as log of 9 plus log of 4. The next property is the quotient property. So when you're subtracting 2 logarithms and they have the same base, you can take what you're taking the log of and divide. So log base b of ilm minus log base b of n equals log base b of ilm over n. So whichever logarithm is written first, that will be the top, that'll be the numerator, and the second one will be the denominator. So log base 2 of 32 minus log base 2 of 4 equals x. So they both have a base of 2, so I can write this as 1 by saying it's log base 2 of 32 over 4 equals x, which is log base 2 of 32 over 4 is 8 equals x. So there it is written as one logarithm, and now I can solve it by putting it in exponential form. So 2 to the x power equals 8, which means that x equals 3. I've got log base 5 of 100 minus log base 5 of 4 equals x. They both have a base of 5, so I can write it as 1. So log base 5 of 100 over 4 equals x, which is log base 5 of 100 divided by 4 is 25 equals x. And now I can solve it by putting it in exponential form. So 5 to the x power equals 25, which means that x equals 2. I've got log base 2 of 32 minus log base 2 of 128 equals x. They both have the base of 2, so I can write it as 1 and say that it's log base 2 of 32 over 128 equals x. And simplifying this, I can say that it's log base 2 of 1/4 equals x, because 32 over 128 simplifies to be 1/4. And now to solve it, I can put it in exponential form. So 2 to the x power equals 1/4. Going from a whole number to a fraction, I know my exponent has to be negative. So 2 to the second power is 4. So 2 to the negative second power would be 1/4. So x equals -2. All right, expanding. So we're going to write it from logarithm to 2 logarithms. So log base 5 of 3 over 10 can be rewritten as log base 5 of 3 minus log base 5 of 10. It's subtraction since it's division in the problem. And log of x over y I can rewrite to be log of x minus log of y. The last property we're focusing on is the power property. So what the power property says is basically if there is a power in your logarithm, you can pull it out to the front and multiply. So log base b of a raised to the p power is equal to p times log base b of a. So here I have log base 3 of 81 to the second power equals x. And we could square 81 and then put that in exponential form and try to solve it, but 81 squared is a big number. So what we can do is we can pull the 2 out to the front and say that it's 2 times the log base 3 of 81 equals x. And now what I can do is I can solve this log right here and then just multiply that by 2. So I'm going to put log base 3 of 81 equals x in exponential form. So 3 to the x power equals 81. And that's going to be multiplied by 2. So 3 to the 4th power is 81. So this right here is 4. So x equals 4. So now I'm just going to multiply it by 2. So really it's 8. So my answer is 8. So log base 5 of 1/5 to the 3rd power equals x. I can rewrite it by pulling the 3 out to the front. So 3 times the log base 5 of 1/5 equals x. And now if I wanted to solve, I could do 3 times, and now I'm going to put the rest of it in exponential form. So 5 to the x power equals 1/5. So 5 to the negative first power is 1/5. So I get 3 times -1. So I end up with -3. My next example, I have log base 1/4 of 16 raised to the 5th power equals x. So rewriting it, I can pull the 5 out to the front. So it's 5 times the log base 1/4 of 16 equals x. And now I can solve it by doing 5 times 1/4 to the x power equals 16. So going from a fraction to a whole number, I know that my exponent needs to be negative. So 4 to the second power is 16. So 1/4 to the negative second power is going to be 16. So 5 times -2, which gives us -10. And that is it for the properties of logarithms for today.